Welcome everybody to today's webinar on technical considerations for PV and storage. Very hot topic in Africa, of course, and especially hot topic in the context of the South African risk mitigation tender. We'll give it just a few more seconds. I see that a few more people are joining in as I speak, and we'll get started just in 15-30 seconds. All right. Well, thank you everyone for joining us today. We have a very interesting topic to cover today, which is large-scale PV and storage projects. As I said a few seconds ago, this is a growingly important topic for Africa particularly, but also around the world, as we will cover during this presentation. We wanted to use the South African risk mitigation tender as a Kickstarter of this presentation, but as you have understood, we will focus on highly technical matters today, and we've got some amazing experts who will be sharing insights with us. Before we delve into the details of the presentation, I know several of you are listening in for the first time and joining us for the first time here at AFSIA. So I would like to give you a very brief introduction about what AFSIA is. AFSIA stands for Africa Solar Industry Association. Our goal primarily is to share information, educate the public about all the benefits of solar energy, specifically for Africa. So we are really like the go-to platform for everything solar in Africa. From large-scale projects all the way down to solar home systems, solar irrigation, C&I projects, mini-grid projects. Anybody and anything that has a component with solar is welcome to AFSIA. We cover the entire continent out of our HQ in Kigali, Rwanda. And we are very lucky to have a small team here in Kigali, but also a network of local representatives in key African countries. What we cover is really like the full industry, from both the technical side of things, but also from verticals. So all the different segments, as I mentioned, C&I, solar home system, large scale, mini grids, everything, but also from the angle of policy, from the angle of technical aspects, financing aspects, all the things that matter to the solar industry are represented within AFSIA. In terms of activities, well, today we are organizing this webinar, but we are also releasing regular newsletters. We do a lot of market coverage through our social media pages. We share information about tenders as well. We have a very well furnished job portal as well, which is popular. And we help our members to get more business in general by connecting them with potential partners. These are a few of our members. I think we're missing some of the latest one here, but you see that they cover a wide range of activities within the industry. And of course, we're always welcoming new members. So please get in touch if you think AFSIA can help you in your business. This is a snapshot of the few activities that we have conducted and will be conducting over the next few months. For some of you, maybe you've heard about the Solar Awards, which we ran end of last month, really celebrating talent and achievements in the solar industry. It was quite popular, and we hope that next edition next year will be even more popular. And then today we have this webinar, and another big milestone is the launch of the annual Solar Outlook report, which we hope will be the most complete outlook on everything solar in Africa ever produced. This is for AFSIA. I don't want to bore you with too much housekeeping. You're connected today because you want to hear about technical considerations of PV and storage. And for this, I'm very, very happy to be welcoming some key experts in the industry. I will give a very brief word of introduction, but they will tell you more about their role and their companies in a few minutes. First of all, we have Lucy from DuPont. Lucy is the technical program manager at DuPont. Kevin Robinson, who is in charge of technical sales at Longi Solar. We have Frederick Vorster, chief technical advisor at PV Insights. And finally, also Davide is joining us today, representing AFSIA, the Battery and Energy Storage Alliance. This is a brief overview of how we will conduct the webinar today. We will first start with a brief presentation of the 2 gigawatt tender and why we believe PV and storage has a key role to play. We will then move into discussing the latest modules technology. A lot is happening on that site, and definitely important to keep up with technological developments. And then we will dive into the importance of quality, especially on product duration. Very interesting insights there from Lucy. She will be followed by Freddie, who will tell us about the reality of solar equipment aging based on hardware data that his company has been collecting, especially for South Africa. And finally, we will close with some very interesting insights on all storage technologies and also some projects, large-scale storage projects that are already happening around the world. Of course, we will finish this webinar today with an abundant Q&A session. And if you have any burning question right now, I invite you to already start submitting those through the Q&A button, which you can find at the bottom of your screen. And we will make sure to address those questions once we reach the Q&A section. So without further ado, we will start with the first section. And I invite Kevin Robinson from Longi Solar to present us a little bit about this tender and follow with some insights about the latest modules technologies. Kevin, the word is yours.
Hi, John. Thanks very much for that introduction, and welcome everybody today. So what I'd like to do is a very brief introduction into Longi, and then a very, very quick overview of the IPP, and then I'll talk about some of the quality considerations when selecting the modules. Next slide, please, John. So just an overview about Longi. Currently, Longi is the world's leading manufacturer of monocrystalline or mono-PERC technology. In terms of R&D spend, probably one of the biggest contributors to research and development, especially in the cell technology. So for example, last year we spent just over $240 million, which amounts to roughly 5% of revenue. Some other numbers there. 4.7 billion in terms of revenue, 730 million in terms of net profit, and then quite a lot of industry recognition from MIT, New Energy China, one of China's top 500 companies. Next slide, please, John. And then in terms of technology, I think this is where Longi really stands out. So currently, in terms of market share of mono wafers, we currently have about 40% market share. Last year shipped about 9 gigawatts of modules, and so far shipped about 5 gigawatts of bifacial modules. And then in terms of bankability, probably the most recognized when it comes to bankability. So Bloomberg, yeah, we're leading there on the Altman Z score, and on the new PV Tech. Well, they launched it about 2 years ago, but the PV Tech bankability ratings for the last well, since the rating started, the only manufacturer that has consistently stayed in the AAA rating. Next slide, please. Okay, so there's a lot of talk about the what they call the emergency round. So basically, it's a technology procurement round for emergency power. They cap it at 2 gigawatts in terms of generation capacity. But I think one thing that's quite important to note is that particularly with battery energy and PV together, that is probably going to be oversized to maybe 3 to 4 times. So potentially in excess of 6 gigawatts of PV if it's the only technology that is chosen. So it's quite, I think, quite important for solar. But it is, having said that, it is technology agnostic. The main point is that in terms of capacity, it needs to be between 50 and 450 megawatts, so quite substantial. But in terms of generation, you should have at least between 50 and 100% available at any given time. And key operational hours between 5 in the morning and 9:30 at night. Automatic generation control is quite important. And then some of the dates. So bid submission was initially set for 22nd of November, but that has been pushed out till 22nd of December now. The preferred bidders were expected to be announced towards the end of December, early January. Now I guess that'll probably move out to January sometime. But I think one of the things that was super critical was the so once you were announced as preferred bidder, you had 4 months to be able to reach financial close. So that's quite an aggressive target, and I think the question is that a realistic target, and what happens? I guess it's probably more realistic to think about 6 to 8 months in terms of closing the projects. In terms of the evaluation, the bids are going to be evaluated on a 90-10 differential. So 90% of the bid is evaluated on price and 10% on economic development. So in the economic development content, there has to be 49% local participation, South African entity participation, with 30% black ownership. And out of that, I think the local content portion has to be 40% local content. It's quite an onerous bid in that all your legal, financial, and technical documentation has to be in place. So in order for the bidders to actually get to bidding stage, there actually is quite a substantial amount of work, both from the technical advisors, financial institutions, legal advisors, and the IPPs as well. When it comes to battery and PV, some of the key considerations for the requirements, 16 days consecutive production will be required, 72 hours at full load. And I think the question really is around bankability of storage solutions. I think that's quite important, both from an investor appetite, but also from a technology and standards point of view. One of the things that is mentioned in the documentation is that there should be a proven track record. So I guess the question is, who is actually going to be able to respond to the PV storage, or the storage aspect of the tender. Next slide, please. So some of the risks. So this is really more of if you're using a fuel source, there should be at least 2 fuel or dual fuel supplies, and the Department of Mineral Energy can ask for a variation in fuel supply at any point of time. The penalties are extremely heavy. So for every delay in commercial operation date, you can be penalized up to 6 days for every day late. As I mentioned, local content is 40%. This is quite high, I think, especially in light of the track record that we have, and the fact that industry has kind of declined. The local industry has declined over the years. One point to note is that the bidders are allowed to apply for exemption. So if they feel that they cannot meet those local content requirements for whatever technology, they are allowed to apply for exemption. And once they have applied for exemption, then it is applicable to everybody who bids. As I mentioned, the documentation is quite onerous in terms of having your financial, your legal, and your technical documentation in place. Timelines, I think it's a super aggressive timeline, and the reality is, I mean, we've already had a month delay. Are those timelines realistic? And so it'd be quite interesting to see what happens with that. And then I think something that's going to be quite interesting is round 5 was supposed to be announced in December. So what's going to happen around projects that are bid in the emergency round? How will we sort of handle the emergency round and round 5? Yeah. So this is another one that was quite important. So although the damages are quite heavy, Eskom can actually almost also terminate the agreement if that COD is not reached. So that's quite a concern as well for the IPPs. I did mention as well, but when it comes to PV and storage, just because of the technical requirements, we are going to need to oversize projects by quite a lot. So potentially 3 to 4 times capacity in order to meet the requirements. And finally, from a technology point of view, is how are the IPPs going to build in some kind of reserve? So your battery degradation, are they going to build in reserves for reserve capacity at a later stage, or some kind of replacement? And how are they going to achieve that? Next slide, please. So why is battery energy storage solutions, why are they important? So this is just a little bit of a summary to show why I think it's an important technology to consider, and I think it really covers everything there. So it's such a the technology is such that you're just able to dispatch and meet various different objectives, and I think I think something that as well is what battery energy storage solutions start to introduce is, once you start to have a rollout of storage in the grid, starts to facilitate more of a smart grid type of solution. Next slide, please.
This is it. Thank you very much for this introduction about the tender. I know it's very, very hard because it's a very large amount of documentation, but thank you for providing us this snapshot. We're receiving already quite a lot of questions, and of course we will keep them for the Q&A section, but I can already answer one question that has come up several times. Yes, the presentation will be shared with you once the webinar is done. And on top of this, you will see in this presentation that Kevin has also prepared additional slides completely at the end of the presentation with more information and more details about the tender itself. So you will get all you need through those slides. Thank you very much, Kevin. And we'll now move on to the second section, which is also presented by Kevin, about important aspects in the latest technologies of modules. Kevin, back to you.
Yeah, thanks, John. Yeah, so it's actually such an interesting space in the development over the last couple of years. I actually stepped out for a bit, but back in the modules game. And it's quite interesting to see how things have really progressed over the last 2 to 3 years. 4 years ago, an IPP project, they would just ask for a 320 watt polycrystalline module, and it's pretty generic. But I think these days there's a lot more consideration into the kind of selections that projects developers are making, or the EPCs are making, and it's making the choices or the design process a lot more complicated. But I think what is critical out of that is the importance of engaging with the module manufacturers at early stages. So, I mean, these days, considering a project, you'd probably start looking at whether you're going to look at bifacial technology or monofacial. If you're choosing bifacial, are you using a glass construction or a glass backsheet construction? And really understanding the bill of materials on what is the impact on your project, should you need to go with or decide to go with either of those technologies. But not only that, it's also got quite a lot more complex when it comes to actually choosing the type of cells. So I mean, currently the cell market is heavily dominated, about 90% by mono-PERC technology, and bifacial is probably about 40% of that. So looking at the cell, it's a choice of what cell size are you looking at. So over the last 3 or 4 years, you've gone from a standard 6-inch cell to 158 millimeters, then to 166, and then the market's kind of just sort of hasn't settled on a standard, but we're looking at now at 182 or 210 millimeters. So there's quite a lot of choice. And then, what is the choice in cell size? How does that actually impact your module? So are you choosing a module with half cell or a third cell, a third cut cell? What is the impact of that, whether you've got 5 strings of cells or 6 strings of cells in the modules? What is the impact of on the bypass diodes? But not only that, there's also sort of the selection between thin film, although it's pretty limited and mostly in the US. And P-type material, we're starting to see some N-type technologies coming. What type of doping are the guys choosing, and what are the impacts? Whether using a cell with gallium doping or boron doping, and what is the impact on degradation? And then, as I mentioned, although the market is heavy mono-PERC dominated, there's still poly-PERC choices as well in the market. Next slide, please. So with these projects, I think bifacial is an important consideration. Obviously, you want to try and harvest as much energy as possible. And once again, I think this is quite an important place to start engaging with the module manufacturers to try and leverage some of the experience. For example, LONGi, we've deployed 5 gigawatts of bifacial technology. 300 of that is in Egypt. So quite a good understanding of the impacts of choosing the technology and design considerations. But there are such a lot of things to consider. And in the early stages of commercial bifacial, the module companies would promote or market certain gains that you would achieve according to certain conditions. But I mean, we really have seen that there's such a lot of seasonal variations in these plants, not only not only from location to location, but actually even within the site, you can have some variations. So I think it's important to start to lean on manufacturers to, when considering some of these things, not only in terms of the technology that you're choosing, but what are the design, how that impacts on the cost of the plant. Next slide, please. So as I mentioned, we are seeing that there are variations in the plant. So it's not easy to with bifacial technology to predict a gain figure. Not only are these gain figures changing according to the seasonal conditions, even day to day or within a month, but because a lot of the case studies have been done on small plants, whether it's 16 modules or 20 modules or something like that, what you start to see in larger plants is that some of the considerations coming through when it starts to see mismatch within these arrays. So I think that's also something that that is important to understand. And I think that's me. Next slide. Ah, yes, okay, sorry. Last point, or last points. In terms of quality criteria, both Lucy and Freddie are going to talk a little bit about this later, but I think, you know, what history has shown is that it's such an important thing to try and involve your module supplier as early as possible, especially in the contracting phases, talking about your acceptance criteria, both in a general requirements, developing a module quality catalog. So not only are your either technical advisor or your own staff able to come and inspect in the factory to qualify that production, but it's also a quality catalog for the operators on the field when they receive the goods, to be able to go through that catalog, do their visual inspections, and make sure that your modules are meeting the criteria. Something else is super critical. We talk about independent lab testing. Why these two aspects, the catalog and the independent lab testing, are so important is that quite often what the module manufacturer does is they will qualify what they call a CDF, which is not necessarily the bill of materials that you would use in your own production. So although a CDF is qualified, it's very important to specify bill of material, and then use independent labs to certify the production. And then also, you know, with some of the long-term degradation or performance issues, very important to define how you qualify the gain for the bifacial modules, and then talk about some of the issues around degradation, long-term degradation, PID, LID, LETID, and then I guess a separate issue, not really pertaining to modules, but you know, seen quite a lot in terms of plant design, how the earthing and lightning protection designs have impacted performance of these plants. So I think it's super critical to pay attention to these points as well. Thanks, John. That concludes my presentation.
Thank you very much, Kevin, and thanks for indeed bringing our attention to all the amazing developments that have happened on the technological side on panel manufacturing. And yes, definitely, I think everybody will have understood the importance of working maybe in a closer way with the module supplier from an early stage on. One of the last points you mentioned was about keeping a close eye on degradation, and this nicely introduces the next section with Lucy, who will tell us about the impact of quality on product duration. Lucy works with DuPont, and DuPont has been conducting a very wide research on the O&M of large plants over the years. And I'm very happy to have Lucy with us today for sharing some of the insights of that work that DuPont has conducted. Lucy, please, the word is yours.
Thank you, John. Thank you, Kevin. If you want to go to the next slide, I will be sharing some consideration from the field. So DuPont is actually a material supplier, and we supply things like the Tedlar film, which contributes to protecting the electrical insulation at the back of the panels. We also make metallization paste, and we make silicones. So you can see that from this vast material play, we had an interest in understanding how panels were degrading in the field. This is what we've done for the past 10 years. We've accumulated statistics on how panels degrade in the field, on all components that constitute the panel. So we've got about 3 gigawatts of statistics spread around the world, on about 550 installations. And this enabled us to determine degradation mechanisms and then reproduce them in the lab. So if you want to go to the next slide, I will show you some of the statistics that we've seen in the field. So 30% of all the panels we looked at suffered from a visual degradation. Now, our surveys concentrated on visual observations. What we know is that a visual defect will not necessarily translate into an operational problem, but some reports, notably on the PV+storage reports task 13, stated that about 80% of the operational problems in the field could be seen visually. I think maybe even with a thermal camera, I would say, more reliably with a thermal camera. So when we look at a panel, we look at the backsheet, we look at the cells, we look at the encapsulant, like I said, at all the components that constitute the panel. And here in our statistics, you see a slight trend to increasing defects. In fact, our statistics are quite stable with regards to age of the panel. So the average age of the years there is about 4 years. So when we go and see an installation, it's at one point in time. It could be 2 years old, it could be 4 years old, it could be 30 years old. Okay, the average age based on megawatts was about 4 years on those observations. Now, we concentrate also a lot on the backsheet defects. You can't, your choice as a module maker, you have to make some choices with regards to materials. What we found in the field is that the choice of backsheets will impact the quality of the panel. So through the processing of the backsheet, you can't really make the backsheet bad. So it's purely a material play at the backsheet level. So we see a lot, some bad stories about backsheet cracking. Some of them are cracking after 4 years in the field, some of them are cracking after 10 years in the field. And I would like to stress the fact that all of these backsheets have been certified. We've gone through IEC. So the IEC certification basically doesn't tell you whether product will age appropriately in the field. Okay, so that's one of the first learnings you need to have. The second one is many times I get the observations that, okay, we've got the warranties from the module maker. The warranties will cover potentially a replacement for a cracked backsheet. That is true. It doesn't cover deinstallation and reinstallation. Okay, so this cost is for you. It will not cover either the loss of power that you suffer during the deinstallation and reinstallation. This cost is for you. So the warranties will not necessarily protect you. They may offset a little bit the equipment loss, so the PV panel equipment loss, but it will not offset all the cost of losing power. If you want to go to the next slide, we'll see. So you don't have to live with all those problems in the field, okay? You can, you will have to be a little bit more technically savvy, and you will have to make yourself some choices and impose them onto your suppliers potentially. So you can get good quality panels. You have to decide that this is what you will get. So you will need to make some choices on the bill of material and tell your supplier, this is what I want, for example. So here, if I place myself in the context of bifacial panels, I would choose to have a transparent backsheet based on Tedlar, because this product has a return from the field after 30 years where it can stand the test of time. I might also make some choices on the encapsulant. If I want to go for a glass-glass configuration, I will not use an EVA encapsulant. So this forces the developers, the owners of the installations, to actually make very pointy technical decisions. Of course, they don't necessarily have the technical knowledge at the start for making those decisions. That's why you need to engage the services of people who can help you with that, like material experts. Very often, the technical consultants are not materials experts, they are process experts. So they know very well the manufacturing process at the module maker. They don't necessarily know the interactions between the various materials at play. Then you will need to check also your module maker track record. Okay, so this will determine the workmanship. So basically, what is your experience with this module maker? And if you don't have an experience with this module maker, what is globally the experience of other people that you know with this module maker? And it's important to check track record. We know that some manufacturers have a pretty poor track record, and we know some others have a pretty good track record. You determine also, Kevin mentioned that earlier, the quality acceptance criteria. That is very important. So what are you prepared to live with? Are you prepared to have cracked cells? How many cracks in a cell do you want? What is the configuration of this crack, for example? And you can, because here you will have the buying power with projects between 50 and 450 megawatts. You have the buying power, you have enough buying power to start negotiating quality acceptance criteria with the supplier. So that's, as Kevin mentioned, involve your supplier very early on in the process. That said, there's no point in setting quality acceptance criteria if you don't go and check them afterwards. So you have to check that they've been met. And you have to tell your supplier, I will come and check that they've been met. It's a little bit like setting a speed limit and never checking that people are respecting those speed limits. Then in this case, the speed limit is worthless. Okay. So now, if you set out all these things, you got good quality panels. That doesn't mean that in operation, you still have good quality panels. So you make sure, you have to make sure that the quality will carry through the process. So again, if you ship the panels horizontally and you badly handle them, then you will damage them. So after shipping, when they arrive on site, you need to check for damage. Then you need to check for damage during or after installation. And this is very easy to do. I think Freddie will probably talk a little bit about that. You can do that by thermal imaging, you can do that by electroluminescence. And then during operation and maintenance, things can happen as well. And you need to make sure that you notified your O&M provider that you will come and check periodically on whether or not the panels are getting damaged through operation and maintenance operations. Okay. All the way through the whole process, it's a matter of saying, this is what I want, and this is how I will check I get what I want. And you don't necessarily know what you want from the start, so you need to get surrounded by people who know what you should be asking for. Okay? I think that concludes my my presentation, John.
Thank you very much, Lucy. It's yeah, very interesting to hear you share common sense topic, but which are indeed often maybe overlooked by project developers. And it's important to reinstate those important aspects in order to avoid any bad surprises down the road. So thanks very much for sharing this. We will be moving to the next section now on solar equipment aging, which will go a little bit deeper in some of the issues that you have identified. And Freddie will talk to us about this. Freddie is the Chief Technical Advisor at PV Insights, a well-known institute in South Africa that has conducted extensive review of PV plants in the country. And so I'm very, very pleased to welcome Freddie to share some of the insights that he's gathered from his work on the ground. Freddie, the word is yours.
Good morning, everybody. Thank you, John, for the introduction. Yeah, I will be showing some nasty pictures, and hopefully you won't scare too many people away. Thank you also, Lucy, for introducing the topic. Yeah, so it's a very difficult topic, so I'm not going to be able to cover everything, but I'll try my best in a short space. Next slide. You can go to the next slide there.
There we go.
Okay, so yeah, PV Insight is a private company, a spin-off company from the university, Mandela University in Port Elizabeth. Just an important thing I think that everybody needs to really understand is, and that is that the cost of photovoltaic system. The best way to lower your cost is to increase the reliability of the system. There's no other way around that. Next slide. So yeah, I'll briefly introduce PV Insight. I'll be just talking about plant assessments, module degradation modes, just really pictures and typical degradation modes observed that we observe. Basically just talking around pictures. Next slide. So yeah, PV Insight is a spin-off company. We do exactly what Lucy was talking about. We will do plant inspections. We we just basically do testing on the modules as a land. There's 5 tests that we do: maximum power, electroluminescence imaging, thermography, high part testing, and visual inspection. We are in ISO 17025 accredited laboratory. So we can do those inspections and tests for you on site as well as in the laboratory. Next slide. Okay, so typically how you'd assess a plant, and we can do it at various levels, but if you go to plant level, the first step would be to do probably an aerial inspection with a drone. Look at your energy yield analysis, look at the SCADA system to see what is going on there. From that, you probably will be able to figure out where the problems lie on the string level. So you would go in and do string IV measurements, string electroluminescence, again, thermography, and then something that's quite new nowadays is fluorescent imaging, which again can give us some indication of what's going on. On the module level, obviously, you can do it on site, but most of our testing takes place in the lab where modules are taken down annually or whenever they need to, and then sent to us where we do the electroluminescence, maximum power, and sometimes thermography inspection. It's rare that we do the high part testing because that could be potentially a destructive test. Many plants opt to do a yearly test. Now the word degradation, aging, it's difficult to say which is the correct word, is quite important because on the same sample of modules we can do those tests and then look at the progression of the modules. Next slide. Okay, so first of all, there's your aerial inspection. You'd look at obvious thermography defects where there could be hot spots and so on. We are busy doing an interesting study on this. There could be some massive misinterpretations of thermal aerial thermography imaging. And basically what you have to do to identify is static and dynamic effects. So there's certainly certain thermographic features that are dynamic in nature and can lead to big errors. So that is very important that whoever you use to do the thermography can do it fast and can do it regular. Next slide. So from the SCADA, we can then get an idea where problems arise, and we do a so-called plant walkabout, looking at plant growth and so on. And these are such obvious errors that plant owners and operators often overlook. But that little bit of shade on one little string there don't just cause a little bit of power drop, it causes a lot of power drop, because it can take out a whole string if the bypass diode is activated. Then in the middle picture there you see also something that is often overlooked, and that is soiling, which is non-uniform. And what happens there again is that if you have non-uniform shading module, you have the potential of losing 1/3 or 2/3 of your module's power. Next slide, please. Okay, so during a plant walkabout, you look for obvious features like backsheet burning that we see a lot. And then very uniquely in South Africa, we've noticed, if you look at the left-hand side there, is basically a film that is formed on the glass, and sometimes that's because of water hardness, calcification. But recently we also noticed in this plant that there's some silicates that actually deposit on the glass, and the bad thing about that is that you can't just wash it off. Your only way to get it off is by mechanical scraping. So what we did here is just to, and that obviously happens at the bottom of the module frame, and it builds up, and again it has a potential to
Yes, I think Freddie might have a little internet problem there.
okay, looks like I'm back.
Are you still with us? Yeah?
I'm back, yeah. All right.
Maybe you might want to try to turn off your camera just to be easy on your bandwidth, and please go on.
Okay, I hope you caught all that. So that deposition of soiling, which can lead to permanent shading, is really an issue in South Africa, and especially modules that are situated between in mining areas. That could be a problem. Then also obvious things that you see on plant walkabouts is snail trails and cracks. This is actually quite a severe crack, and that actually affects your encapsulants as well. Next slide, please. So after you've done your initial tests, you would go and do IV tests on your strings, and you'll definitely notice that if there's modules or strings in the module string that are not happy by looking at that. Next slide, please. Next step would be take it down to the module level and do an IV test or on-site IV test of the module. Next slide, please. You could also, if necessary, do on-site electroluminescence of a whole string of modules. And the advantage of that is that you actually comparing your modules directly. In other words, you're looking at the whole string as a whole. How does it operate? So often you'll find that there are strings, module strings that show dark, and that means it's very, very mismatched with respect to the rest of the string. It does not necessarily mean that module string is out or completely not functioning. It just means it's not actually matched with the rest of the module string. Next slide, please. Okay, so I'm going to go a bit faster over this, but I think Lucy has also alluded to the fact that the biggest problem is actually your modules on plant level. So module defects go up from about 43% of your sources of malperformance on plants. Next slide, please. So just a few definitions, and I think again Lucia has talked about that. Module failure basically tells us that the modules have degraded, the power has degraded, and it's not reversible. It's not just a purely cosmetic issue, whereas the module defect means it's actually not, it's not operating as it should. It's not according to specification. Product specification, as Lucy has said, it doesn't tell you anything about the lifetime of the module. It just simply says, this is how it's made and this is how it's consistently made. So there is an attempt to identify and advance short-term reliability issues on the module design and construction on the product specification. But eventually it is up to you to make sure to test your modules regularly to actually monitor degradation. Next slide, please. So, as I said, it's a very big topic. There are a lot of publications on this, and a few of the important ones I've listed over here. The IEA PV+s reports. The one that's very popular that describes basically all the types of malperformance and degradations is that first one that I mentioned over there. So you're welcome to go and look at those. And I think anybody in the PV business should actually have that on your computer. Next slide, please. So I won't be talking about all that. The things that are described there is, the different stages of your module failures, infant failure, midlife failure, the wear-out failure. Next slide, please. And the resulting, what happens there is your typical bathtub curve, where at initial startup you have a lot of infant failures, which then flattens off. Towards the end of the life of the plant, you will have a lot of wear-out failures, and if you combine the two, you'll see the resulting bathtub type curve. Next slide, please. Yeah, and of course, I think most people are aware of this statistic. Mean degradation that we normally expect per year is about 0.5 to 0.7% per year. In some cases, you have on the long tail end of the module degradation, more than 1% per year. This was a study done by Jordan and Koods from NREL. Next slide, please. So this is typically what we have noticed on some plants. Now, I must also say we obviously we cannot divulge where the plants are and who the plants owners are, but these are just typical degradations that we've noticed on some of our plants. Here is some yearly tests that's been done on a plant since 2014 on the left-hand side, and you can see there's some box and whisker diagram showing the average or the Pmax reduction, and it's roughly about 0.4% per year over that period. And on the right-hand side, you can see there's another plant, also about a 0.3% per year reduction in power. Just on this topic of yearly energy or maximum power point tests, it is very important that when you are planning to do this with us, that you actually identify a calibrated reference module and keep on using the same reference module throughout the life cycle of the plant. This reference module is kept separately in the dark. It's your golden module, and all your modules on your plant is then referenced to that module. If you change the reference module throughout this testing, you are going to get results that are jumping around a little bit like that. Over the long term, you might still be able to get a good idea, but it's very important that from the start that you identify, I would say, 4 or 5 modules that you identify as golden modules, have them calibrated and then used for these annual degradation tests. Next slide. More interesting characteristic is perhaps the fill factor. There you can see how the fill factor changes from year to year. 2014 at the start, and fill factor is really gives an indication of the quality of the module. Next slide. Okay, here's some pictures. Typically, what we see on many plants is this weak finger contacting that you see between the fingers. It doesn't really affect the maximum power of the module or the performance of the module. Next slide, please. It can, however, if there are small cracks that develop, actually cause a big effect, because as you can see on the left-hand side there, small crack, and the weak finger contact actually causes big problems. You also see some minor cracks there, again, not affecting the performance, but over the long term, it can affect the performance of the model, but usually at the beginning, not really. Next slide, please. It's only when those cracks actually disconnect parts of the cell that you start forming hotspots because of reverse biasing and mismatch and so on. That actually becomes an issue. Talking about hotspots, next slide, please. You also got to remember that some module encapsulants cannot handle this fluctuation in temperature, high temperature, low temperature over long periods of time. So there again, very important to have good quality encapsulant materials on your module, because if you have a hotspot for some reason, shading or because of a chip cell, you ideally would like your module to be able to cope with that temperature fluctuations. So that's a typical example of some disconnected cells. And on the left-hand side, you'll see there's a UV fluorescent image of an area of the cell. And if you look at the visual inspection of the module, if you look at the frame, you often notice where those cracks come from. And you can see there at the bottom shown over that. And that's usually because of module handling, not a manufacturing defect. Next slide, please. And this is the backsheet that you often find. A lot of the scuff marks that we noticed on modules that we tested in the lab and on site actually is close to the module mounting points, and you can imagine where that comes from spanners. While mounting the module, maybe the staff are not well trained, and it's regarded as not an issue. But if you look at the electroluminescence image of that scuff mark on the right-hand side, you can see that you actually crushed the cell, and it's almost like eggshell that's shattered. It's not really a crack, it's actually shattered. Again, we do not notice a major drop in performance, but over the long term, you can be sure that it will have an effect. So training of installation plant people that do installations is actually very, very important from the start. Next slide, please. So there again, an impact type crack, most likely from installation or transportation, and that shattering will definitely lead to mismatch and thermal hotspots that will develop over time and can damage your backsheet and your encapsulant. Next slide, please. Okay, again, this is a quick method, and it also shows us a different aspect of the module, and that's the fluorescence imaging. My colleagues know that I don't like just looking at one characterization or one image. I also always like to look at a module from different angles so that you could get different ideas. Now, the electroluminescence gives you an indication of how old that crack is. We talk about mature cracks. Cracks that have actually managed to quench the encapsulant material are normally old cracks. And if you don't notice the crack on the electroluminescent or the UV fluorescent imaging, it's most likely quite a new crack. So on the left-hand side, there are typically scrappy bus bar soldering splats that you can see in the UV image, not visually at all. In the middle image, you can see some shattered cells, sorry. Again, the electroluminescence image will probably show that the cell is pretty shattered. On the right-hand side, typical cracks that you also see in UV fluorescence imaging. Unfortunately, not all modules do quench, or the encapsulants do quench. So some modules, you cannot see any effects on the UV fluorescence. Next slide, please. I think it's the last one. Yeah, so that concludes. That's me. I didn't even talk about LID or PID, which is a major issue still in South Africa, but it's also something that is often misunderstood. We've done some extensive studies as part of a PhD project here at the university on PID. We actually induce PID and observe if we can reverse it and so on. So there's a a lot of studies being done on that. But yeah, time is just too short to cover everything. I'm happy to answer questions later. Thanks.
Thank you very much, Freddie. Yes, as you rightly pointed out, there's a lot of information, a lot of things to be shared and explained on this specific topic. And unfortunately, yes, the format of a webinar does not necessarily allow to go in depth on everything. But listeners will have your contact details, and I'm sure many of them will get in touch with you after today's webinar. Plus, also, while you were talking, we've been receiving quite some good numbers of questions, and probably we will come back on some of the topics that you have highlighted. We have now extensively talked about the PV side of things, but as we mentioned in the beginning of the presentation, another important component of this opportunity here and of the talk today is storage. And for this, we will have Davide tell us a little bit about IBESA's work on this relatively new side of the solar business, and hopefully be able to share also about some successful projects around the world. So without further ado, Davide, I leave the word to you.
Yeah, thank you very much for your introduction, John. My name is Davide Presenti, and I'm representing IBESA and the UPD Research today. IBESA is the International Battery and Energy Storage Alliance, and it's a partner company of UPD Research. The focus of my presentation today is going to be about why renewables plus storage have a role to play for the RFP and under which conditions. Next slide, please. Just to briefly introduce myself and who I'm representing, IBESA is a partner company of UPD Research, and basically UPD Research is providing market intelligence and data to IBESA, while IBESA is a platform which allows technology and knowledge transfers within the solar industry. And UPD Research has been active in the market for 20 years. We provide market intelligence, and our strength is to be in close contact with the key market players. So we are working in close contact with installers, with EPCs, and with distributors. Next slide, please. Here we have a list of some of our clients. We can skip it. Next, please. And yeah, when I start preparing this presentation, I basically start from the three main dimensions which shape the solar market. So basically economy, regulation, and technology. And in order to keep track of these dimensions in a structural way, at UPD Research, we have developed this tool, which is the Global Energy Transition Matrix, or GET Matrix, which contains information on solar developments in 70 country markets, including South Africa. Next, please. The next slide, please. And more in detail, we collect information on some specific parameters related to solar PV. So for example, install capacity per segment per country, or data about electricity market. And next slide, please. But we also do collect information about stakeholders which are active in the market. So we have a long list of the major companies which are active in the downstream segment of each market. Next slide, please. So it was enough in terms of introduction. I want to focus on the RFP. Next slide, please. So here summarize again the framework conditions. Nevertheless, Kevin explained them in detail, so I don't want to focus too much on this. I'm just going to briefly mention some points. We want to procure 2 GW of capacity, and the key requirements which we're going to focus on are being able to dispatch from 5 to 9:30, provide ancillary services, and respect this minimum contracted capacity between 50 and 450 MW. What makes this tender peculiar is that it's technology agnostic. So the 3 main technologies which are going to compete for these tenders are photovoltaic, wind, and gas. So based on this picture, on these framework conditions, we can conclude that there is going to be opportunity for renewables plus storage to play a role for this tender, but we need to understand how and why. Next slide, please. So basically, the 2 key requirements which are necessary to participate in this tender is to be able to dispatch full capacity following the grid instruction, and to provide ancillary services. This is why it's crucial to couple solar with storage, because in this way we will be able to dispatch, and also storage technology will be able to provide ancillary services which are required by the grid operator. But in order to cope with the requirements of the RFP, it's important to keep in mind one thing, that it's important to leverage the key feature of solar technology, which is the modularity. So basically, in order to be able to cope with the requirements of the RFP, it will be necessary to take into consideration the chance to install multiple farms, which are located in different locations. And also, as Kevin mentioned, I agree with him, the solar plant will have to be oversized, because we need to be able to exploit this modularity and the flexibility which is offered by PV capacity. I would like to add one point, since the key will be flexibility for this tender. It will also be interesting to consider the opportunity to also include some wind generation to your power plant in order to increase your flexibility. And the last point is that it's important to determine the optimal size of your battery, and also to determine how many cycles do you want per day. So 1 cycle or 2 cycles. And the second point of this framework, which I define as two steps of an optimization problem, is to optimize the operation and management. Because in order to fulfill the instruction of the grid operator, it will be important to decide how much, when, and how to charge your battery. And the best way to do that is to implement some energy management systems which rely on artificial intelligence and machine learning, and in this way optimizing your operation and your assets. So this is going to be crucial for your success. Next slide, please. So now I would like to present you some market data, and this slide is quite nice because here we see the levelized cost of electricity of different technologies. On the left hand side we see the LCOE of solar and wind, and on the right hand side we see the LCOE of gas. So we all agree about the fact that the LCOE of solar is the cheapest among other technologies. But what we can see here is that, I didn't want to spend too many words on gas in the first place, but what we see here is that gas is quite dependent on gas prices. And also what we see here is that if you consider gas as a technology for this tender, well, we have to take into consideration the fact that we will have to invest in infrastructure, and which basically shows what's the main difference between solar technology and gas technology. So solar technology is going to allow us a lot of flexibility if we couple it with storage. On the opposite, gas will require us way less flexibility and the necessity to invest in infrastructure. And next slide, please. Here, I'm going to show you some the levelized cost of storage for different storage capacities. So we have 3 categories. I would like to, we refer to lithium technology, because in the last years we've seen an increase in deployment of this technology, which is mostly related to a decrease in price, which in turn it was determined by high investment in the e-mobility sector. So the technology became cheaper than in the past. And what I want to show you here is that if we compare the first 2 categories, we see that if we increase the duration of the battery, well, we see an increase in the levelized cost of storage. And that's something which you could keep in mind. Next slide, please. And yeah, observing the market, I also wanted to understand how much grid storage was deployed in the last years. So here we have the development of installations of grid storage between 2013 and 2019. So we see that in the last year, we observed a steep increase, but between 2018 and 2019, there was a decrease of almost 15% in deployment of grid storage. Nevertheless, in 2018, 1.5 gigawatt of grid storage was installed compared to 1.3 gigawatt of grid storage in 2019. Next slide, please. So throughout my research, I tried to identify some projects which are based on solar plus storage. Here, list 2 for reference. We have 2 projects in the US and 1 project in Senegal. I'm not quite sure if the project in Senegal is a microgrid. Nevertheless, I found it interesting because It's developed by ERS and CFM is a company based in South Africa. I don't want to spend too many words on this slide, so we can switch to the next one. Here, I listed 2 projects. This is the Tesla big battery, and which is a big project. We probably all heard about it. It's in South Australia. And basically the key thing which I want to point out here is the timeline of the project. Because as we know, for the RFP, there's a tight deadline, 2022. And what we see here is that, well, this is a huge project, 100 megawatt of storage. But what we see in the project life cycle is that between development and operation, it took only 1 year. So that was quite quick. Next slide, please. Here we have another project still in Southern Australia. It's a hybrid project which includes wind, solar, and storage. Well, it's a huge project which is going to realize through 3 phases, which are going to be of equal size. So let's not focus on the project as a whole, but on the single phases. So for each single phase, it will include 400 megawatt of wind, 200 megawatt of solar, and 300 megawatt of storage. Well, this is a huge project, but still it's give us some information, because what we see is that development is going to take 2 to 3 years and construction 18 months. So given the tight deadline, it's important to keep in mind the timeline of the projects and their sizes. Next slide, please. Now I would like to briefly conclude the presentation. So first of all, solar plus storage is going to play a role for this tender, but it's important to leverage the key feature of solar technology, so its modularity. And also, as Kevin mentioned, it will be important to oversize, it will be necessary to oversize the solar plant, but also I would like to advise you to keep in mind the opportunity to integrate your solar plant with some wind, because this is going to allow you for more flexibility. But the key challenge is going to be the optimization of operations, which is going to be carried out by the energy and management storage system, energy management systems, which the batteries can provide, relying on artificial intelligence and machine learning. Also, the last point which I've seen is that given the deadline, it will be important to decide which business partners you want to cooperate with for your project development. Next slide, please. So I would like to refer to an event which we're going to organize next week in the framework of the Solar Storage DigiCon. It's called Solar Project Development Session. So we invited different project developers, and there you can have some insights about key points to be kept in mind for project development. So if you're interested in receiving more information, here are my contact details. You can contact me, or you can just write some questions in the chat box. Thank you very much.
Thank you, Davide. Thank you very much. Very interesting developments, of course, on the storage side, and very still nascent industry. I mean, when we look at the numbers, it's still, yes, it's growing, but it's still the beginning, and also a lot of technological developments happening there, and probably a lot of curiosity and question marks on the side of users and battery people who will purchase those batteries. In terms of reliability, in terms of marketability as well. This will be quite important for such a tender. And maybe I would like to start with this question. Thank you to all the people who have already submitted questions. We will try to address them all, of course. I'm keeping a close eye on them. So if you have any more questions, please feel free to share them through the Q&A section or the chat box. Something that both you, Davide, and Kevin mentioned is bankability aspects of storage components. How do you currently look at this in light of such a big project that we are looking at for South Africa, but also outside of South Africa? There are more and more large projects. What is your view on the maturity of the technology, how bankable they are perceived by financiers, and what needs to be improved or what is already good. Can you tell us a little bit more about that bankability aspect?
The development of the technology, well, of course, the technology is mature. The key point here is to understand its cost competitiveness. So as I mentioned, it's important to optimize the plan design because the battery is going to be a huge component of your cost. So it's relevant to really optimize the size of your battery in terms of how much generation I want to install and how much and what's the size of my battery, because this is going to have a big influence on the overall cost of your project.
Thank you very much. Kevin, you previously also highlighted the bankability aspect of storage. Do you want to add something on this front?
Look, I mean, I'm not a storage expert, so I think it's just a generic comment. You know, I think in the back of people's minds, we've seen a lot of fires with lithium storage, particularly in South Korea. So I think there's maybe some questions about quality of the battery design and making sure that the cooling and everything is taken care of properly. But also there doesn't really seem to be an international standard around storage, and how do the financiers approach the quality or standards criteria. And then I think it's also important just to understand, you know, what are the technologies that that guys are choosing. Is it a lithium technology? Is it some kind of a flow technology? So I think there's a lot of different considerations that the financial institutions will have to consider.
Thank you. And closely related with the storage, there were several questions, among others, from Catherine, on one thing that you both mentioned as well in terms of the oversizing of PV for this standard. And some people are saying, well, if we need to oversize the PV component of a project, how competitive will it remain? What are your thoughts on this aspect?
Yeah, well,
Lucy, Freddie, anybody. It's an open question to everybody.
Yeah, one point of my presentation was that, again, that plan design has to take into consideration this optimization problem. So basically, yeah, it will be necessary to oversize the capacity, the solar capacity, but this has to still be cost competitive. This is also the reason why I mentioned the opportunity also to complement generation with some wind. Because basically you need to reach as much flexibility as possible. You need to decide on the size of your battery, but then you also need to be able to dispatch according to the requirements of the grid operator. So oversizing your solar plant too much, maybe it's not going to stay cost competitive. Maybe adding some wind allows you to stay more cost competitive and also increasing your flexibility.
Anybody else?
Yeah, I think also just to complement that, you know, the thing is that you can, so part of the RFP or the requirement of the project is that you cannot use the grid to store it to charge the battery. So you need the oversizing of the PV portion enabled for the project to deliver the nameplate capacity, potentially at 100%, but have sufficient energy to charge the batteries at the same time. So that's why you would require the oversizing, is to be able to deliver the energy and charge batteries.
Those two questions were more the tender size, but the tender side of things. But we also have a lot of very technical questions, specifically on panels and testing. Maybe first question for you, Freddie, on the technical side. Several people are very keen for you to explain again what are the pros and cons between UV testing and electroluminescence. Could you, I'm sure we can talk about this for hours, but maybe just explain briefly what you perceive as the pros and cons of both.
Basically, fluorescence or UV fluorescence makes use of a UV light that you shine on the module, and it really shows up where the encapsulant has been quenched, and that quenching happens from water or moisture ingress from behind the module through the backsheet through the crack, So the big difference is that electroluminescence obviously expensive, but electroluminescence will show you when it's an electrical measurement. It will show you when a part of your cell is disconnected or cracked. In other words, when a crack actually has a direct effect on your performance. Whereas UV will just show you there is a crack there, but it won't. It's not an electrical measurement. There's no contacting, which is obviously advantageous, but it doesn't tell you that your cell is, or part of your cell is disconnected. Added to that, you'll have to have quenching first. So it's not something that you can do straight away. You know, the module will have to be out in the sun for at least about 6 months before you can do UV. And of course, your encapsulant will have to be fluorescent. Some encapsulants are not fluorescent. I hope that answers.
Yes, very good. I don't know if anybody wants to add something to this topic maybe, or...
Yes, sure. So basically the electroluminescence is a picture at a point in time of the performance of your panel. And really it is a picture, okay? Fluorescence is the same, but the fluorescence has a timeline to it. Okay, so very often fluorescence could be used, for example, in litigations or claims when you think that damage is happening during a maintenance operation. Okay, so not straight after the maintenance operation, but maybe 6 months after, you could come and do some fluorescence imaging and say, okay, these are recent cracks. Okay, they were not there at the beginning of the operation. They were not there 2 years ago because a crack that is from 2 years ago has this type of appearance. A crack that is 6 months ago has that type of appearance. So fluorescence is attached also with some kind of a gauge of the timeline, which is interesting sometimes in specific litigations.
Yeah, just to follow on that, we often use fluorescence in a lab. If we see a module is heavily cracked and it could be, it could be issues, we will do a quick, take a UV light and just shine on it, and then we can see whether the crack actually happened recently from transporting it to the lab or where it was actually old. And in most cases, the cracks that we see are old cracks or older cracks, so it's not due to transportation to the lab. We often receive modules in boxes falling apart, and the transport is not very, very good. And then we normally would resort to UV fluorescence together with electroluminescence to see what are the timelines of those cracks are.
As you can hear, my cat is extremely interested in UV and EL testing. Sorry about that. Other question, and maybe I'll start, I'll get back to you, Lucy, on this. Several questions that we received about the importance of PID, PID-free panels. People are wondering what exactly is the situation, how should they perceive this, what should they be looking at specifically? Can you tell us a little bit more? I'll start with you, but I'm sure Freddie and Kevin will also have some things to share on this topic later. Yeah.
Thank you. So that's a very good question. So PID is not actually, it's still an actual problem. You can lose a lot of power through PID. So PID is potential induced degradation. And this problem happens as a result of sodium ion migration from the glass to the cell. And those sodium ions will start polluting the cells so that the cells cannot operate to their optimum performance. Now, what induced this problem was cell development, okay? And what enabled this problem was the encapsulant formulation. So it's important to know that, because basically if you want to completely eradicate the PID problem, you need to perform cell development, okay? So you need to eradicate the problem at the cell level. If the problem is not eradicated at the cell level, but rather at the encapsulant level, then you don't have a PID-free panel. You have a PID-slow panel, okay? That's what I usually say. So for me, the tests do not necessarily guarantee you that you have a PID-free panel. They just say, I passed the PID test. But if in the PID test, you lose performance, less than 5% performance through the PID test, then you pass the test. But if you went from 100% performance to, say, 95.5, you've still lost power. That's a PID slow panel for me. It doesn't matter that you passed the PID test. In this case, if the PID is managed through an encapsulant formulation, for me, it remains a PID slow panel. So there's a high risk of developing PID, but slower. So you should put system level prevention measures in place to make sure that you will not develop this problem. So it all depends. Usually I don't believe the PID-free claims. So if you have an area where you will have a lot of precipitation or condensation, I usually advise to go for a system level prevention measure.
Just added to that, maybe why Lucy was talking about the precipitation, and that is a way for the electric field to be strengthened between the cell and the glass, and that electric field is driving the sodium ions. But added to that also, if your module is slightly soiled or dirty, you know, your soiling or your moisture will sit on the glass for longer and actually, you know, I wouldn't say accelerate, but I suppose it can accelerate. So that's another reason for keeping your modules clean of soiling, especially in a moist environment or where there's a lot of precipitation that doesn't wash off the soiling.
Kevin, what is your view on this PID topic?
Yeah, I think similar to Lucy. So I think it's important to consider your power plant design. Take mitigation. Well, actually consider it during your power plant design. A lot of the inverters these days have automatic PID recovery boxes, so that could potentially be an option. But yeah, I think it's very important to distinguish between what is termed PID resistant and PID free.
Just a quick word. I would like to thank Catherine. Apparently, there's been an amendment on the tender with regards to the 6 days penalty. And I understand from Catherine's comment that this has now been removed. So I'm sure that everybody looking into this tender will be very happy to hear about this. And also a small comment to Joe. Joe was very interested in DuPont's reports. And yes, this report has been published, and we will make sure to share the link to the report in the follow-up email after this webinar, so that you can get easy access. And yes, it's a very interesting report with lots of data, especially on a very, very large sample of projects. One other question from Gary. We've talked extensively about the degradation of solar panels, a very important topic, of course. But Gary is wondering about the degradation on the battery, on the degradation of the battery in hot weather temperatures. And I wanted to ask Davide his opinion on this topic, and if we already have sufficient data to evaluate that aspect, and how do batteries compare, how do they react in certain conditions?
Well, I cannot give you a straight answer on this point, so I do not have much records about where there have been problems regarding installation in hot weathers. Nevertheless, what we've seen is that there are big batteries being installed in Southern Australia, in Nevada, in the US. So probably there is enough development which has been done in technology to cope with that. If you want more specific information, I will have to do some additional research. But well, looking at the project which have been realized so far, there's a way to cope with that.
Thank you. Now I would like to switch to another group of questions. I understood from your respective presentations that actually the human factor plays a very important role in degradation and defaults. And a few of our listeners have shared questions about this. Martin is asking about the impact of trackers, active trackers as opposed to fixed tilt. Is there any evidence that trackers generate more defects on panels, or is it a completely safe tool to be used on projects? I don't know who wants to take a crack at that one.
Yeah, we have seen some problems on trackers, but then it's usually not because of the tracker, but the tracker design. Especially if the tracker is orientated so that there is, you know, that wind can cause flexing of your table. Flexing of a table can also happen in fixed orientations. It is very, very important that your module is mounted firmly according to the manufacturer specifications, and that I'm saying exactly according to the manufacturer specifications, not to the table manufacturer. It's very important that happens. So we've often seen that bad tracker design has caused or induced cracks in modules. But we have seen some very good tracker designs where it is absolutely, you know, it's only, you can only gain from that.
Yeah, I think.
Go ahead, Kevin. Yeah.
Yes, similar sort of opinion, but you know, I think that you know, you can never beat good design. I think a lot of the issues actually come around, well, in my experience, come around operator issues. So maybe during cleaning or operation and maintenance stages, guys actually climbing up on the arrays. Have seen situations where there's a radiant sensor and the guy scrambled up the array, played around with the radiant sensor, and then sort of slid down the modules again. So I mean, it's those things that I think are more important, sort of in the O&M stages.
That is often evidenced by the lower row of modules that we noticed that are cracked.
Lucy from DuPont's.
Yeah. You have to remember that the panels don't just operate themselves. So intrinsically, if they're kept in a clean environment without any vegetation and any dust, then okay, you can probably leave them be, but that's not the real life. So if you let, for example, Freddie showed some pictures of vegetation in front of the panels. We've seen these kind of things in the field just before thermography, which is a shame. You have to schedule your ground maintenance so that you optimize your production. It's a trivial observation, but we've seen this kind of things happening at the peak summer production in Europe, and vegetation growing all in front of the panels, and the maintenance team is actually on holiday in August. And that just can't happen. If you want to work in solar, you're going to have to do your ground maintenance when it makes sense for the panels, not when it makes sense for the people.
Thank you.
I think just to add to that, often people think that it's simply a case of losing a little bit of revenue, but you can actually damage your modules if you have that reverse biasing from non-uniform shading onto the modules.
I'll give you an example of how long it takes for to damage a panel from partial shading. It can take 5 days in Switzerland. So you can shade one cell for 5 days in Switzerland, and you will start seeing some damage in some of the materials. And then if you leave it longer, you're going to start putting at risk your installation, because a cell that is subjected to high temperature for a long time will start losing its shunt resistance. So in this case, you will start developing shunts. A shunt is a very high intensity hotspot in a very localized area. And in this case, you can even break the glass. So you will lose the panel entirely if you're not careful with the maintenance of your grounds.
And building on this, we had another question from this time an anonymous listener that also happens. What are curative measures once you identify cracks or backsheet issues? Is it too late and do you just regret that you haven't made the right choice, or are there solutions to actually fix or at least moderate the problems?
So it depends. So yes, you first regret you haven't made the right choices, and then you try to think how you're going to remediate the problem. So if you've got, for example, cracked backsheets, there's more and more of them in the field, and this problem, because it's growing stronger, there's solutions. Okay, when we have a problem, a widespread problem, usually we find a solution. Okay, that's how we're designed to react to problems. So in this case, because the problem is fairly widespread now, there are solutions coming onto the market. Now, there are some good solutions and some not as good solutions. So for example, when you have a cracked backsheet, you can come and repair the backsheet, okay, under certain criteria. DuPont has actually developed a solution for repairing backsheets, which will be commercial early next year. And to develop these solutions, we wanted to reach the end of the expected lifetime of the panels. So we've actually applied test sequences that allow us to develop confidence in this solution. A lot of the other solutions that have been developed are just designed to take the panel to the end of the warranty. Okay, so the warranty usually on the panel will be 10 years. So these solutions are designed to last 3 or 4 years. The solution we designed with partners, and module maker partners sometimes as well, is designed to last till the end of the expected lifetime of the panels. Okay, the way you do that is through appropriate testing. So again, you don't just rely on any sense for how long the panel will last in the field or how long your solutions will last in the field. You need to apply sequential testing. Okay, so this is what we've done. If there's any more information required, we can share this information. Now, for cracked cells and for hotspots, there's not a lot you can do. Okay, Freddie, maybe you will add to this. Once you've got a cracked cell, its performance is damaged. Okay, so you have to monitor your situation so that you don't put your whole park at risk. So you need to make sure that you don't generate further damage through fire, for example. We've seen junction box fires sometimes through operating bypass diodes. So it's just a question of monitoring the situation to mitigate the risk to the other panels surrounding the damaged panels. And sometimes you will consolidate and separate.
Yeah, I think it's very important to distinguish the type of crack, the disconnect type of crack, which disconnects part of your cell, which will cause hotspots. Those are serious and should be addressed immediately. Cracks that don't disconnect, especially the ones that run parallel to the bus bar, probably not as serious. And the only way to distinguish between the two, unfortunately, is with electroluminescence. You won't be able to see that with UV. It's usually a scare tactic to walk through a plant with a UV light. Plant owners get very scared very quickly, but you have to explain to them, yes, you have a lot of cracks, but some of these cracks are not going to cause performance losses immediately.
But eventually, Freddie. It will do eventually.
Eventually it will, yeah.
Thank you very much. I'm in the terrible position of having to make choices among all the questions that we have received. Would like to thank everybody who has submitted questions, and also say sorry that I'm looking at the time and definitely it will not be possible to address them all. But if you have submitted them through the Q&A section, this will be recorded, and I will share these with our panelists today, and hopefully it will be the nice start for a good conversation on some technical aspects and for them to follow on with you. I have to make a choice. Two more questions. Someone is asking me about the advantages or disadvantages of dry cleaning and the potential of affecting the quality of the panels. Is there any data, any insight that you can share on this type of cleaning on projects and maybe some pros and cons?
Yeah, look, I think dry cleaning is well recognized, and a lot of the automated processes these days using robotics and artificial intelligence cleaning, doing that automated power plant cleaning. In terms of actual documentation, no, I don't have anything, but maybe that's something we can look into. But I think important considerations is just to consider the type of brushes that you're using, so that they're not too brittle and start scratching or damaging the coatings on the glass. There are also a lot of advances in some of the coatings that you can apply to glass. So you see a lot of, for example, DSM is one of them, where you can apply a coating to the glass, which does assist a little bit with the cleaning. I think obviously the biggest benefit is you don't actually have to use water consumption. I think especially in hot, dry climates where you have water on site, where you have to go and wash panels, it can be quite a wasteful process.
Yeah, as I mentioned earlier, to add on to that is that, often if you use water, the module is not dried immediately, it's left to sun dry, and that's exactly when you have these deposits actually forming on the glass, and especially the silicate deposits, which you cannot, there's no chemical way of getting it off. You can treat your water that you're cleaning your modules with, but yeah, in the end of the day, I think that dry cleaning is probably the lesser of two evils, if you can go that way.
Thank you very much. Two more questions, two quick ones. Is there an ideal schedule of inspection and maintenance? And if the answer is yes, please reveal the secrets.
Yes, to some extent there's an ideal schedule. So there's an extraordinary schedule. So every time you come to the end of a warranty, you should make sure that before you come to the end of the warranty, you have appropriate inspection, okay? Because you might want to put in a claim. It's better early than late. Every time you do a change of contract, so if you want to change, for example, your O&M provider, you need to make sure that you assign the right damage to the right provider. Every time you want to change your insurance provider, we've seen that as well. So if you have an insurance changeover, the second insurance will say, well, no, actually that was pre-existing damage. So you need to be able to prove that it isn't pre-existing damage. And then obviously you need to regularly check your plants. So I would say a yearly schedule seems fair to check the plants. Drone thermal imaging to check for any power losses, and then you do also some visual checks on the plant.
Thank you. Freddie.
From a PVI perspective, obviously as often as you can. That's our business. But I would definitely say that one must be careful with drone thermography. It can lead to erroneous results, but as a first stab, as a high-level initial check, it's always good to do that. Many of the plants in South Africa send their modules down to us every year, and that seems to be a good way. So yeah, yearly checks, very important, on site or in lab.
Thank you. And then maybe the last question, I think I would ask it first to Kevin, but of course open to everybody else. Alison is highlighting that the price of glass for the glass panels has been increasing recently. The question being price increase potentially affecting the competitivity of those panels.
Yeah, so I think glass, the glass issue is a market condition. I think at the moment it's probably a short to medium term problem. We kind of see it going into probably 2022. So I think part of the reason is that just the demand for PV has just grown so much. And I think that a lot of the suppliers haven't really caught up. So I think this year or next year, the forecast is for something like 160 to 180 gigawatts. And, you know, with 80% of the production being in China, I think a lot of the guys are struggling to keep up with demand. And then what has added to this, of course, is the demand for bifacial, where the guys are using dual glass. So it's effectively double the requirement for raw material. So yeah, I think it is a short to medium term problem, but I think it will be resolved. I think it also depends on what happens with the Chinese government. So a lot of the discussion at the moment is to see how the Chinese government can step in, because there has been a shortage of raw materials. Obviously, the guys are profit taking advantage of the situation. So yeah, a lot of guys are a little bit unhappy, and seems we'll see what happens with the Chinese government, whether they step in and trying to moderate.
Thank you. Anybody else on this topic of glass and increasing price of glass? Nope. Apparently you've said it all, Kevin. Very good. Well, yes, again, this is the third time I'm saying it, but I'm really sorry for all the other questions. I'm looking at the clock. It's been almost 2 hours. And I think, yes, maybe we're going to call it a day for today. I would like to thank our panelists today. Thank you very much for sharing these insights on very important topics for the long-term success of projects, including PV and storage. But of course, I would like to thank the listeners as well who stayed with us for almost 2 hours. Thank you very much. We will follow up with you with the slides as usual, with the link to the recording of this webinar, which you can find on our YouTube channel. And as I said, I will also share the additional questions that we did not have time to address right now with our panelists. And hopefully this can be a starting point of an interesting discussion between you, not under this webinar, but in a more direct email way. Once again, thanks to everybody. Very happy to have you today. And I hope we will be in touch very soon again. Thank you and have a great day.
Thank you.
Bye-bye.
Thank you.
Thank you, John.
Bye.
Thank you, participants.